Lecture 2, definition of Kronecker delta and Levi-Civita symbols. This is the definition of Kronecker delta. Delta ij is equal 1 if I is equal j. Is 0 if I is different from 0. You see? Attention now from the previous lecture. Two free index. Okay? It's two free index. I could be 1, 2, 3. J could be 1, 2, 3. So this corresponds to 9 different components. Okay. Now, Levi-Civita epsilon ijk. You see, 3 free index. 3. This will be plus 1 if ijk is an even permutation of 1, 2, 3. I'll show you clearly how to play with this. Epsilon ijk is equal minus 1 if ijk is an odd permutation of 1, 2, 3. And 0 if any two indices are equal. I'll give an example here. So, delta ij ai. Now, attention, previous lecture. I here is dummy. J is free. So, I can expand this 1j a1 plus delta 2j a2 plus delta 3j a3. Easy. You see? I dummy and j is free. See? Now, since j is free, you see that j is equal 1. Then, this relation here, delta 1, 1, a1 plus delta 2, 1, a2 plus delta 3, 1, a3. It's quite simple. See, I'm summing, okay, on I because I is dummy. Look, I could set, for instance, another dummy here. Doesn't matter. I would put here, for instance, k. You see, this is dummy. 1, 1 plus 2, 2 plus 3, 3. The sum in k. You see? Let's maintain I over here. Quite clear. By definition, you look here. By definition, this delta 1, 1, you see, here I is equal j. So this will be 1. This I is different from j. This will be 0 and this will be 0. See? So delta iji is equal, for j is equal 1, this is equal to a1. Now, j is equal to, you see, the j is free. So j is equal to delta ij ai is equal, you see, I substitute here j by 2. So this I have delta 1, 2, a1 plus delta 2, 2, a2 plus delta 2, 3, j is equal to, okay? So this on the left here, in this case, see, it's easy, you see? I have here 1, 1, 1, 1, the sun, 2, 2, in this case, okay? This is j is equal to, this I'm summing, okay? You see, j always will be here, you see? Look, j always will be here, because j is equal to. So this is, in this case, 3, 2, a3. It's quite simple, you see? This is the place of j. You see what I mean? Look. This is j. J is equal to, j is equal to, and j is equal to. It's easy. So the sum is the same because so this here now will be 0 because delta 1, 2 is 0. This will be 1. See? This will be 1. Why? Because in this case I is equal j. I is equal j here. This is 1. And this will be 0. So this will be equal to a2. Likewise, for j is equal 3, you can conclude. You see, look at that. J is equal 1, I have a 1. J is equal 2, I have a 2. J is equal 3 by induction, okay? Delta ij ai is equal a3. See? It's very, very simple, okay? Now, you see, for you to get practice, you see other examples about Kronecker delta. So I can conclude here delta ij ai is equal aj. Quite simple, because I is dummy, j is free. You see, j is equal 1, a1. J is equal 1, a1. J is equal 2, a2. J is equal 3, a3. I can say it like that. Now, let's go to Levi-Civita. You see? I'll give an example. For instance, epsilon 1, 3, 2, for instance. Okay? Let's write here. Let's put the P example. P, let's say P1. See? P1. You see, a trick. 1, 3, 2. 1, 3, 2 is an even permutation or odd permutation. Do always like that. You write down here 1, 2, 3. Then here you put 1, 3, 2. See, you repeat this here and put over here. Now you link. 1 is 1, 2 is 2, and 3. I have one intersection. I said one intersection. See? So this here implies odd permutation. Since it's odd permutation, this value here is -1. So this is -1. You see, later you're going to see other properties, application of the Kronecker delta and Levi-Civita. Okay? From now, it's okay. This is the lesson 2, definition of Kronecker delta and Levi-Civita. You go to the lecture 3. Okay?